So feel free to let me know if you have any questions or whatever that you may have, suggestions, concerns. Other exams. Is it easy? Is it difficult? How are you guys finding the course so far? Are you solving the assignments? I'd be happy to listen to your feedback if you have any. Okay, very good. Okay, so make sure you are solving the assignments. I think the exam is gonna be very soon, guys. Maybe not next week, but probably the week after. Okay, and the exam will be online. Okay, guys, last time I asked you guys a question, and I want to make sure that we are all on the same page. You said if you have an elevator, okay, in an elevator and it is going down with a constant velocity, okay, the elevator and its payload have a weight of m. What do you think the acceleration or the tension in the cable would be?
mg.
Mg. Why mg?
We use the second law of Newton. We sum the forces equals to the mass times the acceleration.
Yeah, exactly, right? But the acceleration only would be what?
Zero, because the velocity is constant.
Yeah, exactly. Okay, I have another question for you guys. If the elevator is to actually go up, let's say, right? Can you move it up so that the tension in the cable will always be equal to mg, or it must change in order for the elevator to move up?
I think it should increase.
It must be greater than the tension in the elevator must be greater than mg.
Yeah, like let's say you have an elevator that is suspended, right? And you have a cable here, you have a tension here. Let's say the elevator was at this position, right? And this is my x0, this is my reference. And if I want to move this elevator to this point, I want to call that x1, right? Could it be possible that I move it from x0 to x1 without changing the tension? Like tension as a function of time.
Because as soon as there is an A, بيصير في extra tension.
Exactly, bravo, yes, me with me. As soon as you want to move the elevator, it means that the velocity will change. If it was just stationary, the minute that you want to move it, it means that you have to accelerate it, right? And then the minute that you actually have to accelerate it, then the tension has to be equal to m. We know it, g plus a. مظبوط? So the minute that you want to move the elevator, right, it will actually develop acceleration, right? When an object move from rest, right, the velocity is going to change, right? Because the velocity was 0 and now it's moving, it will have some velocity, therefore it will have some acceleration. And as a result of the acceleration, basically the tension will change, right? So later on, what you guys will do, you will learn, like feedback control systems and how you actually control stuff. When you move an object, obviously you basically control t as a function of time, right? By mean of controlling the voltage on the motor. You control the tension. Tension will control the acceleration will control the velocity, and the velocity will control the position. Ultimately, you're not really controlling the acceleration, you are only controlling the position, right? So later on, you're gonna take control systems, I think it was Dr. Ahle, and you're gonna learn how to actually apply voltage to be able to move that elevator here, maybe as quickly as possible, or you wanna move it slowly, etc. So dynamics is basically the bedrock for controls and dynamic system analysis, vibration analysis. All right, very good. So what I would like to do is I want to actually do one more example today. And let's say you have a table. Okay, let's say you have a table and you have a hole in the middle of the table. Okay, and then you have a wire that is suspended from here, and then you basically have like a sphere or something here. All right, and that sphere is basically rotating. All right, and then it's rotating. It has a tangential velocity of v0. Okay, Can you guys tell me what would be the tension? Let's say this length here is equal to a radius of r. Can you help me out to find what is the tension in this line here? What would be the tension in this line? How do I solve this problem?
AN times
Yeah, but let's do the basic stuff, right? We said Newton's law
sum
was
of the forces أول شيء.
right. We said Newton law F is equal to ma. مظبوط. نحن we are going to
Yes.
analyze this part of the figure, right, by drawing a figure, and then this part by drawing. So here we're going to draw figure 2, and then here we're going to draw figure 1. And really, I would like you guys to apply this for as long as you are doing dynamics. You know, after LAU, you choose to get a master's anywhere else, PhD, whatever. Always apply this method so you will never actually get confused between the forces and the acceleration. Okay, so what are the forces that are applied on this object? And obviously, I have to tell you that the mass of this object is m. How can I do a free body diagram on here?
There's
So
the
what-
mass, mj, and the tension in the cable.
Okay, the mass is not, so we have to say force of gravity, right? So mg will be at the center of gravity of this object, which is the center, right? So this is mg, right? By virtue of existence, right? You actually, by virtue of existing on the surface of Earth, we actually all have this mg applied at our center of gravity. That's one thing. Okay, so what are the external forces? ما هيك hell external forces, not internal.
دكتور ما
Tension
فيني هو
and
الام
reaction.
فيني هو الام جي هي رياكشن اوف ذا سبورت
Yes.
No. So mg is a weight that is applied here at the center of gravity of this mass. So by virtue of existing, this mass will actually have an mg because it's near the surface of the Earth. That is applied at the center of this. Now we want to see what are the other external forces which are applied on this object. What
The
are the
tension
other?
in the cable and the
Exact-
reaction of the cable.
Bravo, exactly. So this is how you should analyze it. So we have the tension in the line, right? This is another external force that is applied on this object, right? And then we have what? We have the reaction from the table, right? So the table is also trying to apply force on it. Right? And then let's call this as N. You guys agree? And that's
يا
it.
دكتور ما قلت لك ما فيني اعتبر الام جي ايكوال للرياكشن اوف ذا سبورت قلت لي لا
No, you cannot. You actually have to solve it. And then you will deduce that N is equal to mg, right? But N will not be equal to mg if you actually have some acceleration in a vertical direction. So when you do this figure,
كانت
you-
horizontal بتبطل.
exactly, if ما كانت horizontal بتبطل, exactly. So what you want to do here is you want to always put all the external forces, and then you will solve for it, and then you will actually tally. Okay, now I'm going to go on this diagram on my figure 2, and I'm going to put the accelerations. What are the accelerations that are here? Inertial acceleration. What should I put?
AM and AT.
AN and AT.
M, exactly. So it's MA. Here we're talking about inertial forces, right? Okay, so here I'm putting the inertial forces, and then عندنا هون the acceleration, right? So this figure is actually drawn in this plane, right? In the plane of the paper here. So we're looking, what are we going to have? We are going to have what acceleration? MAN only, right? Because this guy is rotating in circle. So the only thing that you can actually have is, you said you're going to have an acceleration toward the center of the circle, right? Which is this, along this direction. So this guy is going to be equal to what? What is the value of this vector?
MAN.
Okay,
Oh,
what is
minus.
what is AN? In this
V
case,
square over
Squared
R.
over R.
exactly. So
V0 squared over R.
MV0 square over R, exactly. If I have AT, what should I put AT on this diagram?
طلوع ونزول.
No, it will actually be in that direction, right? In the direction of the pen. You agree?
Yes.
Okay. So MAT would be in the same direction. So here I would actually have to have another force here, but we're saying V0 is constant, so we're good. Okay, so the question was find the tension in the cable. How do you find the tension in the cable?
We sum the forces
Yeah, okay. So
equals to MA.
So you're gonna sum the forces, and then here you're gonna tell me the direction, right? So let's say I use this to be my positive direction.
دكتور ليش خدت الام في سكوير اوفر ار على to the left؟ ليش مش to the right؟
We said the normal acceleration will always point toward the center of the circle, right? Okay, so this acceleration is pointing toward the center of the circle. Okay? The center of the circle is here, right? Does it make sense? If I'm looking at the
اي
table,
circle قصدك السفير ولا التيبل؟
no, toward the center of basically where the rotation is actually happening. So if I'm actually looking at a tail from top, I'm going to see this, right? So you're going to see that, you know, this is the rope is coming like this, and then this is the ball, right? If the ball is moving here with a velocity v0, then this is acceleration, right?
اوكي
مظبوط?
يس مظبوط.
Okay, deal. Okay, so I'm gonna sum the forces in that direction, and you know, whatever that I do on this figure, I have to do on this figure. So if I'm summing the forces on the right direction, so I'm gonna look into this figure. I want to see, you know, what are the forces that I have in the right direction. And actually, what do I have here? What should I write now?
minus tx.
Minus t. لا ما في tx, just t, right? Whatever that we wrote here, right?
Okay.
Minus t, okay. And then what?
Equals minus v0 squared over r.
Okay, deal. So this is what we have. So basically, the tension is going to be equal to v0 squared over r. Okay, so and I'm pretty sure most of you have kind of experimented. You know, you have like a rock, for example. If you tie a rock or an object with a rope, and then you try and spin it, you will see that if the velocity increases, what happens is the tension. If your velocity increases,
tension will increase.
Increase.
Exactly, and then if the radius decrease, also the tension will increase. Okay. All right. So the other concept which I'm going to go over is well, first of all, I'm going to actually go over the presentation the way we have it from the course. All right. So this is chapter 13. We started by discussing the tension in the cable of the elevator. We have here where in this chapter we are going to link you know, the accelerations that we have previously obtained, right? And then we're going to link them with the external forces. And the way we are going to do this is by doing these two figure approach. Okay, one figure we put the external forces, and on the other figure we're going to put the inertial acceleration or inertial forces. I'm sorry, inertial forces. It means whatever accelerations you have, you multiply it by the mass. Notice that the reason why we call it inertial forces is because these forces are applied at the center of gravity of the object. Okay, just like what you have mg, because mg is kind of a form of acceleration, but we're treating it as forces, so we'll just do m times a, but we always have to put that at the center of gravity of the object. So you know, just quickly going over Newton's law of motion. You know, we have, if a particle is at rest, it will actually, or in moving in a straight line with constant velocity, it will remain in that state if no forces are applied at it, right? Which makes sense, right? So you know, for you to be able to change the velocity, right? You always have to apply. You'll have to have an acceleration, right? And then when you have an acceleration, it means that you have to have enough force. Right, so always for you to be able to change the direction of an object that is going in a constant velocity, you always have to apply a force to move it. Okay. The second law is this is what we did. Basically, F is equal to ma is the second law, and then the third law is that if I have two objects and the forces is equal and opposite between them. So here, in the case of this guy, the force between the sphere and the table is equal and opposite, right? So if I was gonna do a free body diagram on a table, what do I get? I'm gonna actually put n on a table, right? If I were to do it here, let's say, you know, if I want to do a free body diagram on a table, then whatever that I have the ball, basically, I'm gonna put n on it, right? And then I'm gonna put mg of the table. What are the other forces that I have on a table? Can someone tell me? Let's say the table has the weight of m.
At each support, there's a reaction.
Bravo. So I'm gonna have, let's call them R1 and then R2.
Can we say also friction, doctor?
There is friction. If it was moving, then there would be friction. But when it's not moving.
Ah, okay.
And there's its weight.
The weight. Where should I put the weight?
At the center of its gravity, in the middle somewhere.
Exactly, bravo. So here, the CG of this doesn't actually have to be on the actual part, right? It would be sometimes in the air. So this is the free body diagram on a table, and then this is the mass of the table. Put it mg at the CG of the table, and then n is what? Equal and opposite, right? So if I'm doing a free body diagram on the ball, basically I'm putting n here, and then this n is actually also the same n basically is also on the table, okay? This is how later on you'll be able to analyze, multi-body systems, right, or multi-link systems. Is you will
بس
basically
دكتور ما لازم نحط كمان ام جي بالعكس الام
no, you
كانت
can,
البول.
no. So when you are dealing with that, basically you just have to put this is the interaction force between this object and another. Whether this force is equal to mg or okay, what happens if I actually have let's say somehow I actually have a0. Okay, let's say this object is flying in some weird direction. Then is n is equal to mg here?
No.
Why? How would n change if I actually have ma0?
If we sum the forces, we have ma on the other side, and so it won't be equal.
Exactly. So this is how you want to be very careful, right? So if I sum the forces in vertical direction, I want to have n minus mg is equal to what? Minus ma0. So a0 is actually interfering with n is no longer equal to mg now, right? Because I have accelerations here. So this is what I want you guys to understand is that just keep n as an interaction force, right? And then this n is you put it on the table and then you put it here and then you're just gonna continue your analysis.
دكتور اوكي فهمت عليك بس انت بالبول اول شيء حطيت ان وحطيت ام جي رجعت حطيت على التيبل ان بعكس الان وام جي ما لازم احطها بعكس الام جي.
I don't understand what you're saying.
هون الفري بادي دايجرام تبع التيبل مش تبع البول، يعني ما بتاخد رياكشن بين البول والتيبل.
So this is a free body diagram on a table, right? And then this is a free diagram on the ball. Okay, I can't wait. We have to move forward. You know what I'm saying? Try to watch this. If you don't understand it, just let me know, and then we can, I'd be happy to discuss more. Okay, so this is this force here is that this is a interaction force between two objects. So the fact that you have any two objects with some masses, basically, you actually have this interaction force. This is a force that actually keeps the moon orbiting around the Earth. This is the same force that actually keeps satellites orbiting around the Earth, basically. That is the force. It's called the force of attraction, basically, between two bodies. Okay, deal. So I think these are all clear here. If you sometimes in our textbook, sometimes weight is given to you in pounds. So you always have to divide it by 32.2 to actually to continue your analysis when weight is given to you in pounds. It's like if I give you the weight of an object in Newton, right? How do you actually get the mass? You always have to get the mass by dividing it by, like, let's say 9.8, but we don't do that in the SI system. But in an American system, basically, sometimes the weight is given to you in pounds. So like I said, you divide by 32.2, which is g in feet per second square. So you can actually get the mass, because sometimes you want to multiply the mass by V0 square over R, right? It's not always g. So you get the mass by dividing the weight, which is in pound, by 32.2, and then you multiply it by V0 square over R. Let's say in that example where V would have to be given to you in feet, right? Or feet per second. Okay, guys, I think this is all easy. The procedure here is basically what I just put here, but we have here the other thing that we put the forces and then those externally. And then needless to say, so here we're analyzing 1 degree of freedom. Obviously, you can send the forces in the X, in the Y, and then also in the Z, right? So you would have that three things. Next thing that what I want to do is I want to actually go over friction. And I think friction is a very important topic that, many people get confused sometimes easily, but once you understand it, I think it will be very simple for you. Let's say if I have an object, okay, and this object basically is, kind of sliding on the ground, okay? Let's say the object has a mass m, and I'm trying to basically pull it with a force F, okay? Let's say now I have friction. And friction is going to be defined based on two coefficients, okay? So mu k and then mu s. So mu k is called coefficient of kinetic friction, and then this guy is coefficient of static friction. What you should understand here is that the mu k will actually apply when the object is moving, and then mu s is the maximum friction force. So if we were actually writing what is my friction force, right, which is in this case, how would the friction force look like? It's going to be opposing the motion, right? And then I'm going to label it like that. So what is my friction is going to be equal to what? So it will have a maximum value, right? So the maximum value, so I'm going to say so the maximum value for friction is going to be equal to mu s times n, where n is basically the normal force. All right. So the maximum value for friction is equal to mu s times n, and then the value of the friction will actually be equal to mu k times n when object in motion. So the minute that I actually begin to move the object, what is going to be the friction equal to? Like when the object is beginning to move, then the friction will be equal to how much? Mu k times?
Mu k times n.
Okay. If the object is not moving, what is the maximum value of the friction that it could actually have? Mu s times?
Mu s times n.
Okay. So this is the maximum value. The maximum value, remember. Okay. The maximum value. Okay, and I want to teach you this, guys, by doing an example. Okay, let us actually look into this example. Okay, and maybe we can put some numbers on it. Let's say, you know, the m is equal to 1 kilograms. Okay, and you know, let's say mu s is equal to 0.3, and then let's say mu k is equal to 0.1. All right. Okay, so let's draw a free body diagram, and then let's actually find the acceleration of this object as a result of applying different forces. Okay, so here, let's do, I'll repeat one more time. So let's find the acceleration of this object as a result of increasing the force, given that we have this friction condition. So let's do a free body diagram. How would the free body diagram look like on here? So in this figure, we're gonna put the forces, right? What are the
We're
forces?
gonna have F,
Okay, very good. So we're gonna have F,
N,
N.
the friction, and the mass, mg.
Okay, so I have mg. Okay, what about the friction? What would be the value of the friction here?
Mu kn.
No, here's what. Okay, so we don't know the value for the friction. Okay, these are basically like discrete values for friction. Okay, so we don't know these. We would put mu k times n if we know that the object is moving, right? But how do we know if the object is moving? So what we will do is actually we're going to put simply f, because we don't know the value for the friction. Deal? So we don't know the value for the friction, but here, what should I put on the acceleration diagram? We're going to put MA, exactly. So we're going to put MA here, and here basically, you know, we don't know what A yet is. So let's sum the forces in X direction and see what happens. So if I sum the forces in X direction, I'm going to get basically F minus F is going to be equal to MA, right? And then I'm going to use this to be able to find the acceleration. Deal? Okay, so if F, let's say F was equal to, you know, 0.1 Newton. Okay, what is the value for the acceleration?
We need to know the friction.
We need to know the friction, exactly. So how do we know the value for the friction?
First, we need to get the normal force by getting its mg.
Okay, so well, if we sum the forces in vertical direction.
In the y direction, yes.
In the vertical direction, I know that I'm going to have n minus mg is equal to 0. So n is going to be equal to mg. So we actually have that, right? Okay, so if the force is 0.1, right? How can I, basically I have two unknowns. I have the friction and then I have the acceleration, right? So what do I know about the friction, right? So if the force, okay, is below.
So mu kn.
Okay, so here's what we'll do. So if the force is less than the maximum friction, will the object move?
No.
No.
No, doctor.
So as long as, right, as long as F is less than the maximum friction, which is equal to mu s times n, then what? Then what is going to happen? And the object will not move, right? So the first thing, which, and then n is equal to mg, which is equal to mu s times mg. Okay, so let me find this value, okay? And then so long as 0.1 is below this maximum friction, then I know this guy is not going to move.
Doctor,
So let's just quickly do that. So what is the maximum value for the friction? So I have my 0.3, right? So it will be 0.3 times 1 times 9.8, right? Which is almost 0.3, right?
Yes.
Okay, almost 0.3, okay? So as long as 0.1 is less than 0.3, what is the value for the friction?
0.3 ولا 3 بتصير؟
Yeah, 3.
Almost 3 doctor مش almost 0.3.
3, exactly. So if I'm increasing the force on this object, then what is the value for the friction? Then will the object move or no?
Here it won't still until it reaches 0.3.
Until it reaches 3, right? So as long as the force is below 3, then what is my acceleration?
0.
Exactly. So what would be the value for the friction force?
It's gonna be equal to the force that's pulling it to the right.
Bravo, me, exactly. So as long as the object is not moving, right? As long as my force is below my maximum friction force, then my friction is actually equal to my pulling force, right? Which makes sense. Let's say you have a table, right? And you are pushing the table. The table will basically, the friction will be exactly equal to the force that you are applying on a table, right? If your force is greater than the maximum friction force that you are applying on a table, then the object will begin to move. Then the friction will actually have 0.1 or mu k times mg, and then you can find the acceleration based on that. All right, guys. So here, what some people sometimes make a mistake is, so what they will do is they will simply put f minus f, and then they treat f as f max. So you actually end up with a negative number, مظبوط. So 0.1 minus 3 will be minus 2.9, and then you can tell me the acceleration here is equal to minus 2.9 divided by the mass, right? But the friction cannot actually move the object backward, right? So here we'll only test the movement to see if you actually have the movement. So when you actually have friction analysis, what you have to do is you want to find the maximum friction force, and then test if there is motion, right? If there is no motion, then acceleration is 0, right? If F is greater than the maximum force, then you will actually have an acceleration. Does that make sense?
قصدك الستاتيك فريكشن هي لما تكون object not moving?
Yes, exactly. The maximum value of the friction when the object is not moving. This is F max. All right. So what is the procedure that we just did? So basically, first of all, find the maximum friction force, right? You want to find the maximum friction force, and then you will compare basically to see if F is greater than that. If F is greater than that, then you will actually have acceleration, right? And then if F is greater than that, then how do you find the acceleration? So let's say now F is actually equal to 4 Newton. Can you find the acceleration based on F is equal to 4?
F is greater than F max, so فينا نحسب.
Okay, how do you find the acceleration?
استعمل UK this time لأن movement.
Exactly. In that case, you're going to use mu k. Exactly. So it's going to be F minus mu k, right? Times mg is equal to ma. So now A is going to be equal to F minus mu k mg divided by m. All right. So this is how we can find the acceleration, okay, of this object if it was moving, right? So obviously you'll never have mu s if an object is moving. So there is 2 situations that could occur right here. That we did is, first of all, you can find basically the first thing that you want to do is you want to find if F is greater than the maximum friction force, and then if it is, basically when there is motion, then you're gonna update your F to be equal to mu k times mg, and then you find F. Or another way, what you should do is you can put F minus the maximum friction force and then find the acceleration. If the acceleration is negative, right, it means that this force cannot create any motion. Friction, meaning the friction is greater than whatever force that you're applying. Motion is not possible. Then you will stop right there. Then you get the friction is equal to F, right? If you do this, if you basically test F minus mu s mg and then you actually find A and A to be positive, it means that the force is greater than the maximum friction. Then basically you re-update the friction, make it equal to mu k times mg, and then you can solve for the acceleration. Okay, so once you do some examples on that, you will understand it very well. What I want you guys to know out of this exercise is that the friction will always be equal to the force that you are applying, right? So long as the friction is below mu s times mg, right? Once the friction is greater than mu s mg, it means that the object will move, and then you can find the acceleration of the object. Okay, let's actually jump and then quickly do this example. And then I think this is the best way for us to really understand how to actually analyze this problem. So what we have here is that we have this 50 kilograms crate that is starting from rest, and then it achieves a velocity of 4 meters per second when it travels a distance of 5 meters to the right. Okay, so it's starting from rest, and then it reaches a velocity of 4 meters per second when it travels a distance of 5 meters. All right, so we need to find the magnitude of the force that is applied on the crate, and then they tell us that the coefficient of kinetic friction is equal to mu k, which is equal to 0.3. Okay, we need to find P, right? Okay, can someone help us out to solve this problem?
أول شيء بدي أقسم P
We draw the free body diagram.
Bravo. أول شيء you want to do a free body diagram, right? So let's do a free body diagram. Okay, so we actually have P. Yeah, we can divide P into two components, or you can keep it
X
like
and Y.
we can keep it like that, and then we know P cosine 30 is in the x direction, and then we know it will be P sine 30 in a vertical direction, right? Okay, what are the forces that are applied on this object?
mg,
We have
reaction,
And
friction.
Friction.
what is the value for the friction in this case?
Moving,
UK.
so
What is the value for the friction during this movement?
UK times N.
Why is it mu k times n?
R يعني. لأنه it's moving.
It's moving, exactly. They are already telling you that the object is moving, right? So definitely, so mu k times R. Okay, how about on the right figure?
MA to the right.
عندنا MA منقسمها كمان للMA.
لا ما بنقسمها. We only have one MA. It's not going up, right?
إذا عندنا الفورس XY MA كمان بتكون XY.
مظبوط.
it's moving بس in the X.
It's moving in
Not moving, but
yeah, it's moving only in X. So okay, so we need to find P. Do I know A?
Yes, it's
How?
delta V over delta. No, فينا استعمل from 0 to 5 and from 0 to 4 and 5 meters.
Okay, how do you find acceleration? Guys, we have 2 minutes to solve this problem.
ADS equal to VdV.
ADS equals VdV.
Yes. Equal to VdV, bravo. Okay, so we're going to integrate that. So هون ال A is constant, مش هيك? And a constant acceleration. How do you find so it will be A S ما هيك equal to V square over 2. So A is equal to V square over 2S مش هيك؟ اللي هي 4 square divided by 2 times 5 or 16 over 10, which is 1.6. Okay, we got the acceleration. How do you find P?
P is 30 cosine. Sorry.
لا you want sum the forces ما هيك؟
Yeah.
I'm in X direction.
So P cosine 30 minus شو؟ mu k times r, right?
Equal
Yes.
MK. MA.
MA ما هيك؟ So I have A, do I have R? How can I find R?
We sum the forces in the Y.
G plus P sine theta.
Sum the forces in y, so it will be R مظبوط plus P sine 30 minus mg is equal to 0, right? So what is R? Is
Now we have two equations, two unknowns.
mg minus P sine 30. So we got that. So I'm going to replace R into here. So I'm going to end up with what? P cosine 30 minus mu k times R, which is mg minus P sine 30 equal to MA. Right, so let's factor out P. So I'm going to end up with P cosine 30 plus mu k sine 30 minus mu k mg وهنا عندنا MA, right? So it will be MA plus mu kg. So what I did is minus mu k mg زحتهم لهون وأنا factor out M. So what is the value for P? MA plus mu k times g, divide that by cosine 30 plus mu k sine 30. Okay, so maybe we should try and then do this. How do I actually get the value for that? So what is the value for the mass here that we have?
50 kilograms.
So, okay, so 50 multiplied by 1.6 plus mu k, which is equal to 0.3 times 9.8, right? The whole thing is divided by how much? Cosine 30 plus 0.3 times sine 30. Okay, it will be 223.4. Okay, so 223.4 Newton. Okay, guys, so that is it regarding this. So what I'll do is I'm gonna close this and we'll try to solve one more problem basically. Okay.